Hi everyone, my name is Charles Tian. I am a rising junior in University High School in Irvine. And my project's name is AI Birder, an intelligent mobile application to automate bird classification using artificial intelligence and deep learning. And this is an overview of the slide today. First I will state the problem that I'm trying to solve with my app, and then I will have an introduction of my app, as long as a prototype of my finished app, some testing procedures, the results of those testings, and a discussion, conclusion, and future work. So first of all, the problem I'm trying to solve and trying to achieve with my app is identifying bird species without needing internet using a portable artificial intelligence system. And the problem is I am a huge birder. I enjoy going bird watching in my free time. But identifying birds in the wild can be a really arduous task, and too many existing birding apps are too complicated to use and take too long to give an accurate result due to bad internet connection. Another type of identification that birders use is using a field guide, which is like a little book with different pictures of birds inside it. And the hard part of using field guides is that you have to manually flip through all the pages, find the bird, and then sometimes the field guide might not be complete, or the birds, you just can't really see the bird well. So yeah, I had a really hard time using the field guide myself. So I decided to move on to birding apps. But while many existing apps like Audubon requires the user to input trace of the bird, which are often hard to identify for inexperienced birders. So I plan to design an app that can identify the bird with just an uploaded image. So for example, here, all right, yeah, so this is an example of the Audubon birding app. And here you can, the app makes the user to input size, color, bird type, activity, habitat, and so on. And for inexperienced birder, all of this might be hard to actually remember and to upload, except for the size, I guess, and the color. So this is not really accurate and not really effective for inexperienced birders. Instead, with my app, the users can find out what the bird is with just an image uploaded. They can either upload a picture to the app, or they can take a picture right now and then upload it to the app. An introduction to my app. The app is developed using Flutter, a software development toolkit developed by Google. Basically, everything is coded in Dart, a coding language that's very similar to Java. And then for my data set, I will be using Firebase to as the backend portion of the app. Firebase is database service system that provides data storage for a server for hosting. And finally, TensorFlow is used as a library that contains materials needed for AI engines, and is what I will be using for my bird identification portion of the app. And my goal of my app and the functions are being able to identify birds without internet connection. The AI engine should be on average at least 70% accurate, and then the database must be flexible and able to expand to and adjust to new bird species. This means that because there are thousands of bird species in the world, I definitely cannot include all of them in the first first update. So that means I have to update and then include more birds as people people find new birds in the world, and also want more new birds to be added to the app. And finally, it must be a working app that can be installed. And here's a prototype and a basic flowchart to my prototype. So first, there is a login page with a create account and forget password button. This is just a normal login page, and this will be linked to a database. The whole project will be linked to a database with username, and then and bird species and images. And then it comes to the main page, where there will be a list of birds that has been discovered by the users already. And this can be, for example, house finch, Canada goose, bald eagle, and that will be just a list of birds that you can scroll through and then just like look at them. And if you click on a picture of a bird, it will show you to the list of all the birds that all the pictures that have been uploaded to the app. And finally, we have two buttons, one in the top right, that will be upload a picture. That means the user can click on that, upload a picture that will be probably stored in their phone album or their hard drive, and or they can take a picture using bottom right, and they can just take a picture like in the wild. And then the last page will be an AI identification page, which the algorithm will return 3 species that are the closest to the bird to the picture, and it will tell you on what percentage of accuracy it is. And then there's a button that you can upload a picture and species to the main page. You can choose to not do that. It doesn't impact the app that much. And then finally, there's database images used to train the engine, and AI code model, which compose of the AI engine algorithm, which then will be implemented into the app. And yeah, and the users can directly contribute to the app by discovering new birds and uploading their pictures to the app. For example, as I said, there are so many birds in the world. What if the birds that they saw is not on my list? And if they're 100%, if they're really certain that their birds is not in my list, they can still take a picture and then upload it using the correct name. I have so basically, then my app will have another bird, a brand new bird, and then I will see that, and I will therefore add all these pictures to ensure there's a new species added to my list. And the AI engine is also going to be using on-device training, meaning that the identification part of the app does not require internet, so that the user can use the app anywhere to go. And then finally, to test my, to train my AI, engine, I definitely need a lot of data. So like a lot of bird pictures for each species of bird. And there's no way I'm going to collect all of those in the wild. Especially I don't live near all birds. So therefore, I use a bulk image downloader that allows me to collect hundreds and thousands of bird pictures easily from the internet. And that is a great source of data for a database. I can access basically any species of bird without actually leaving my house and actually looking for them. But the problem is it needs a lot of cleaning to ensure accuracy and the quality of each picture. And my testing procedure, I'm mainly going to be testing my AI portion, not the app portion, because there's not much to test for the actual app. So for testing my AI engine, I randomly selected 5 birds from my database. So in this case, I chose red-tailed hawk, northern shoveler, mourning dove, black phoebe, and bald eagle. And then also from online from the internet, I downloaded 5 random pictures of each bird, and then I uploaded to my app to see the accuracy for each one. So here's example of the 5 different pictures for bald eagle, and here's like the 5 pictures that will be used for testing my AI engine. And then on the bottom there is a example as a result. For example, here this image my app returned that is 99% sure that this is a bald eagle, which then the user can upload it to the app or not. It depends on them. And then this is a example of a example of a result, and therefore I have all these 5. I have 2 species of birds right here, and with all their percentage of accuracy recorded. And this is the example of a data collection for the model with epochs equals 13. And epochs is the number of times the AI engine will retrain itself using the training data. The epochs is a variable in my training code, which will determine how many times the code will run itself. For example, here on Epix is 13. That means my AI engine will retrain itself 13 times using all the data set and all the pictures that I have. And the result of the first model is an average of 55.2%, which is below the 70% required stated in the criteria. So therefore, I revised my prototype and experimented with different Epix value, since that is mainly what determines the accuracy. So I increased it to 15, 17, 19, and then although there was some increase in accuracy, the model with Epix equal 19 was overfitting. That means the AI engine has trained itself too much with the training pictures, so it can only identify the training pictures. For if there's a random picture on the internet, it cannot successfully identify it. This is called overfitting. And then I tried decreasing the number of epochs to 11 and 9, where I found 11 to be the best out of all the models and 9 to be too inaccurate because it hasn't trained enough yet. And here is the graph of basically all my models with different epochs values. And you can see 11 is the highest with around 79%, which is above the 70% that I was aiming for. And then after testing with the Epix equals 13 model, I found that the percentage for accuracy for bald eagle was low. And I found that my dataset with golden eagles had many pictures of juvenile bald eagles in there. So that means my dataset at first, since I downloaded a lot of them beforehand, I didn't really check a lot. So therefore, the folder with my golden eagle pictures have many juvenile bald eagles in there. And if you search up on the internet, those two look really similar. The golden eagle looks very similar to a juvenile bald eagle, which hasn't developed a white head yet. So people usually get it mixed up and upload juvenile bald eagle pictures as golden eagles on the internet. So after I deleted the invalid pictures and cleaned my dataset, the accuracy for bald eagles improved significantly, as you can see from the graph on the bottom. And then lastly, when I'm trying my app out, I realized that whenever I upload a bird image that has like a flying bird or another bird with female or juvenile birds, the app doesn't identify well. Therefore, I added more pictures in the database about flying birds or birds in motions, and also female birds and juvenile birds. Because sometimes when birds are flying, they show different feathers, and those feathers can be different colors, which will mess up the AI engine. And female birds and juvenile birds look for some species, they look very different from their adult. For example, the mallard, female birds don't have the green head, while the male ones have a bright green head. And here's the result of 100 pictures, 200 pictures, 300 pictures for each flying birds in a training data set. And on the bottom is how many pictures of female birds that I included in the training data set. And for both, the accuracy went up with increased number of pictures. And then discussion on my final prototype, the model with Epix equals 11 did reach my criteria with an average percentage accuracy of 79%. The app also works offline, as I tried it on my phone and other people's phone as well. And the AI engine is also able to expand for new species. I can simply update the app to add a new bird, and I will add the training and data set to make sure the birds can be identified. And then this app can also be downloaded in the Google Play Store or the iOS App Store. And overall, the engine can be improved. For some birds have a higher accuracy than others. And the model with Epix equals 11, the average percent of accuracy for northern shoveler is 83.2%, while the percent of mourning dove is only 57.0%. And the reason why is because for some birds, they have more distinct coloration compared to others. For example, a northern shoveler has a distinct coloration and clear pictures from the internet. They have a green head, a brown belly, and then like and then some white feathers around the belly. Meanwhile, the mourning dove has an overall dull coloration. It's basically just brown and gray, and it has it has many images that are really close to other birds. So I fixed that by adding more accurate pictures of mourning dove, and also checking the pictures of similar birds. Just similar to what I did for bald eagle and golden eagle, I basically cleaned out the golden eagle database, and then my bald eagle accuracy went up. And also for balancing out the accuracy for one of the models with epic 11, I had a greatest maximum value with northern shoveler at 99%, but the percentage of mourning dove was only at 23.4%. Meanwhile, my model with epic 11 has the percentage of northern shoveler at 83.2% and the mourning dove at 57.0%. I chose the model with epic 11 because to a user, a 99% to an 83% is not that much a difference. They're pretty positive that the bird is identified correctly, but at 23.4% might throw people off because that is way below the 50% line, and that might make every like user uncomfortable. So therefore, the one with 57.0% is way better for the users. And overall, my AI engine was similar to experiments done by scientists from Kimberley, South Africa, and the Muta University of Karak. So basically, they use deep learning to identify birds as well, and they also use CNN, which is convolutional neural networks, but they didn't apply it to like an app or like a software so that everybody can use it. So so basically, my app allows more people to accurately identify birds, and it opens up AI identification for birds to more people. And in the conclusion, I was able to create an app that identifies birds without the internet. And then it is also available to download on Google Play and the App Store. And with my app, birders can cut down their time spent trying to find the bird in their field guides or on the internet and spend more time actually looking at the birds. And here are some example of the main page of Air Birder, which basically have right here, the first one, American Kestrel, bald eagle, and Baltimore Oriole. So you can click on the pictures, and it will bring you to a list of pictures of that bird. And on the right, that is a sample result for house finch, which shows that it is 97% accurate as a house finch. And my future work is to clean out all most of the invalid images in my database, therefore increasing my accuracy for every bird, and also adding more pictures of juvenile female birds of the different bird species. For some birds have really distinct differentiations between the two. Also, bird identification by call or audio will also be an useful addition to the app, because most of the time you cannot really see the bird really well. You can only hear it in a bush. So maybe have a call, have identification by call will help the user significantly. And yeah, that is my presentation. Thank you for listening.